Hey guys, this is video 6 on the EVT, IVT, and MVT theorems. I'm going to start with the IVT. So you have this chart, it's all filled in. I just want to read through it and kind of give you the real important parts here. So I'm going to start with the IVT. Now with the IVT, if f of x is continuous on a closed interval, and there's a number k between f of a and f of b, then there exists at least one value c in AB such that f of c is equal to k. Okay, what does that mean? So first of all, one of the most important things here is that f has to be continuous. Now if we look at this graph, what this is saying is between a and b, there's some value k. Now k is a y value. There's a k value that has to exist between that a and b if f of c, one of these x values in between a and b, is equal to k. Another way of saying this is just that it's going to hit every single y value between f of a and f of b. Between the y value for a and the y value for b, there is going to be a value for every single y between it. We talk about a lot in the beginning of the year about like when you eat a hamburger, you gain weight, right? Because you're eating something. When you're gaining weight, do you go right from 120 pounds to 122 pounds? No. First you have 120.1 and 120.2, and you exist at every single interval between 120 and 122. So every single weight has to be hit because between those y values there has to be one of the y values in between it. That's what the intermediate value theorem is saying. Now when you're justifying the intermediate value theorem, the most important thing is you have to say it's continuous, even if the question says it's continuous. So let's do an example of justifying. I'm going to jump to the easy one, EVT. So with EVT, that's the extreme value theorem, extreme as in extrema, and extrema as in the max and the min. So again, super important that we realize it's a continuous function, f of x on the closed interval from a to b, so here's a, here's b, this function is continuous, and that means that it's going to attain an absolute maximum such that there's a highest point, and an absolute minimum such that there's a lowest point for all x in the interval. Very simply, it just means that every continuous function is going to have a max and a min. Okay, so every continuous function has a max and a min by the EVT. In order to justify this, you have to prove it's continuous. So here's how I want you to justify it. The last theorem I'm going to talk about is the mean value theorem. That's the MVT, that's the middle one here. So if f of x is continuous on the closed interval, a to b, and differentiable on the open interval, a to b, then there must exist at least one value c in AB such that f prime of c is equal to f of b minus f of a over b minus a. This should look familiar. This is just average rate of change, right? An average rate of change we learned about in the beginning of the year. Average rate of change is just the slope of the secant line. So we have the slope of the tangent line, that's the instantaneous rate of change, that's the derivative. And we have the slope of the secant line, that's your average rate of change. Now, what's important about that, here actually, maybe I should draw this picture out. Here's your slope of the secant line. Oof, that was bad. Here's the slope of the secant line, and here's the slope of the tangent line. We're saying that at one point C, they're going to be equal. Okay, so like at this point, the slopes are going to be equal. That means that their derivatives are equal at that point. Okay, so the mean value theorem connects the average rate of change and the instantaneous rate of change, saying they have to be equal at some point, which allows us to use the average rate of change to find derivatives. So when justifying this, you have to make sure you say the function is continuous and differentiable. I want both. Your justification is going to say the function is continuous and differentiable. Yes, differentiable means that it's continuous also, but you're going to say it to make sure that they know that you know that differentiability means first you have to prove continuous. Okay, so even if the question tells you it's differentiable, make sure you still say it. So justifying with the intermediate value theorem, this is on the next page. The blue is the way I want you to justify it. Since the function is continuous on the interval, and blank is between f of a and f of b, this is your y value. IVT applies, so there is a value, this is your x value, such that f of that x value is equal to the y value. It's going to make a lot more sense when we do an example, so let's try this one. This red one is your example. Function h is continuous on the interval from -2 to 11, with h of -2 equals 0 and h of 11 equals -20. Must there be a value c on the interval -2 to 11 such that h of c is equal to -17? Okay, so first thing I'm going to do, I'm going to start out by saying, okay, h of -2 is 0. H of 11 is -20. They're asking me if there's a c such that the y value is going to be -17. We'll see how -17 is between 0 and 20, 0 and -20. That means that yes, it's going to have a value c by the intermediate value theorem. So let's justify it like we did above. I'm just going to copy what I had before, above because I want the same explanation. So since the function is continuous on the interval, and we're going to say our y value, right? So our y value is -17 is between f of, we're going to change that to h of -2 and h of 11. IVT applies, so there's a value, this is c, such that f of c, this is really h of c, is equal to -17. Okay, so that's how I want you to justify the intermediate value theorem every time. Say it's continuous on the interval. Say that the y value is between the two y values given. So IVT applies, so there must be a x value, c, or some letter, such that h of c is equal to -17. Okay, let's try another theorem. When you justify the extreme value theorem, you want to say, since the function is continuous on the interval, you have to say it's continuous even if the question told you it was continuous. By the EVT, there must be a maximum and a minimum. You could say what those maximum and min are, but that's going to get you full credit, just that explanation, if you have to justify anything with the extreme value theorem. Alright, so here's your justification for the mean value theorem. Since the function is continuous and differentiable, oh, that's a typo. Since the function is continuous and differentiable on the interval, and the average rate of change is blank, whatever the average rate of change is, you're going to do the average rate of change and fill it in, by the MVT, f prime of whatever I'm looking for is equal to the same thing as the average rate of change. These should be the same, because I'm proving that the instantaneous rate of change at that point that they're asking me about is the same as the average rate of change. So let's do an example. Here's my example. Does f prime of c equal 0 for some c, where c is between 0 and 4, if the function f is differentiable? This must have autocorrected. Bull. Okay, so I have this table here. I'm looking at the interval from 0 to 4, so I'm looking at the whole thing. I want to know, does f prime of c ever equal 0? Which means I'm trying to see, does the average rate of change ever equal 0? Well, looking at this, you notice that these values, these y values, are the same. So think about the average rate of change formula. You have f of b minus f of a over b minus a. So in order for this to equal 0, I need f of b minus f of a to equal 0. So f of b minus f of a means I need 2 points that are going to be the same. So I could put in between 1 and 3, I know 1.5 minus 1.5 over 3 minus 1. That's going to be 0 over 2, which is going to equal 0. So yes, this is going to work. This is actually a more specific question of the mean value theorem, because this is actually called Rolle's theorem. Rolle's theorem says that if you have 2 points where the y values are the same, then you're guaranteed to have an instantaneous rate of change at 0 between them. So that makes sense, right? Because I'm plugging in the y values that are the same, which means my top of my average rate of change fraction is always going to be 0, which means I'm going to have an average rate of change of 0, which implies instantaneous rate of change of 0. So let's put this together into our justification. I'm going to put it right up here into these blanks. So I have, since the function is continuous and differentiable on the interval, and the average rate of change is 0, by the MVT, f prime of c is equal to 0. Okay, and the important thing is you're going to do this justification, but you're also going to make sure you show the work for the average rate of change, and you're got full credit. Okay, so justifying the mean value theorem, keep that in mind.